Hi guys, in this video we'll be doing another machine learning project called rock versus mine prediction. So let's say there is a submarine under ocean and it has to predict whether there is any rock or there is any mine. How? With the help of this ultrasound actually. So it will release the ultrasound and it will receive some data. Based on this data parameter, it has to predict whether it's a rock or whether it's a mine. Now for this, we'll be using some sensor data. We call it as a sonar data. I'll tell you from where you will get the data. So first of all, let's see the workflow, how we are going to solve the problem statement. So guys, this is the workflow. First of all, we'll be getting the sonar data. Then we have to do some data preprocessing step. Then after that, we'll be performing tentative split operation. Then we'll be training one logistic regression model. Okay, you can use any kinds of, let's say, model here. So it's a classification problem statement. So here you have to predict whether it's a mine or whether it's a rock. So logistic regression is a classification algorithm. You can use any kinds of classification algorithm here. Then once I train the model, then we'll be using the training model to perform the prediction on top of the new data. So user will pass the new data, new sensor data, and this model will predict whether this is a rock or it's a mine. Okay, so this should be our prediction. So let's start the development. So for this, what I will do guys, I will open up my Google Colab. So there will be doing all the coding. And if you want to convert this project as an end-to-end pipeline, guys, I already have taken two actually project there. I showed you in the entire pipeline how to create. Even I also showed you how you can integrate the MLOps tool. If you want, you can also update the project with respect to that. So guys, let's start the development. So here we'll be performing the entire notebook experiment. That means everything we'll be doing in the Jupyter notebook, and we'll try to train the model, and we'll also do the prediction of the model. So guys, here you can see this is the data we'll be using. So this is actually sensor data. The name of the data is sonar data. This data is also available over the Kaggle website. If you search on Kaggle, we'll also get the data. So what I have done guys, I have already downloaded from the Kaggle and uploaded it in my Google Drive. So this is the link. I'll share the link. From there you can download the data. So let's open up our Google Colab. So to open up the Google Colab, just try to search colab.research.google.com and just try to open it up and create a new notebook here. So now just try to name the notebook. I'll give, let's say, rock versus mine. So now let's connect the notebook. So after that, what we have to do guys, we have to upload our data. Just try to click on upload button, and this is the data. Let's upload it here. So you have to download it guys first of all, then you have to upload it here. So let me import some necessary libraries. So I'm going to import numpy as np. Then I need pandas. From pandas as pd, and I also need tentative split to perform the tentative split operation from scikit-learn. So scikit-learn dot model selection import tentative split. Okay. Then I also need something called logistic regression. So from scikit-learn dot linear model. So it is falls under linear model. So import logistic regression. Okay. Then I also need accuracy score. So from scikit-learn dot metrics input accuracy score. So accuracy score is the metrics for this one, your classification problem statement. Okay, so let me import all of them. Okay, so it is giving me one error. So okay, import pandas as pd, it would be, sorry. Yeah. Okay, now see, everything is imported perfectly. Now we have to load the data. So to load the data, how I can load guys, just call pandas.read. It's a CSV file. You can see the extension is a CSV file. So let's call read CSV. Inside that you have to give the location. Just try to copy the path, and here just try to paste it. Okay, now let's store inside a variable. I'm going to name it as it's a sonar underscore data. Okay, now let me load it. Now if I show you the sonar data dot head, so guys, you can see this is the data, but here you can see this column name is coming okay, it's a number. So what I will do, I will try to replace this number with just like 1 2 3 4 like that. So for this you have to mention this parameter header is equal to none. So now if I show you, see now actually it is now readable. Okay, now you can see it is having 60 column. Okay, 60 column, and the last column is the target column. So here R means it's a rock, and you will see M means it's a mine. Okay, and these are some sensor data actually I have. So based on that we have to predict that particular let's say object. Okay, so now if you want to see the like how many let's say record you have here, so you can simply write this code. So sonar data.shape, so this will print the number of record you have. So here you have 208 rows and 61 actually columns, because it is starting from 0, that's why 61 columns are there. Okay, and if you want to see the statistical analysis, so you can just write describe sonar data.describe. You can see the mean, standard deviation, okay, 25% percentile, 50, 75, and max. So I think you already know. Okay, in statistics you have already learned these are the parameter. Fine. Now if you want to see like how many let's say rock and how many mine example you have in the entire data, so you can see that, just write sonar data. So the number of column name is, it's a 60 maybe, let me show you. Yeah, 60. So let's give 60 here. Okay, 60 is the label. Okay, now here I will just apply value counts, value underscore counts. So it should, so here you can see it is showing mine you have 111 and rock you have 97. Okay, so it's not imbalanced data, it's completely fine. So here M means it's a mine, R means it's a rock, guys. Okay, remember. Now we have to separate out our X features and Y features. So instead of 60, all of the data is my X and 60 is my Y. Okay, so how to separate? So you can write X is equal to sonar data dot drop. Which column you have to drop? You can specify column. I want to drop 60 column, 60 number column. Okay, and axis, it's a column, I will give 0. Axis is equal to, sorry, axis is equal to 1. Okay, so this will give me the X, and if I want to take the Y, so Y is equal to sonar I'll take the 60. Okay, this one. Now if I execute, now if I show you my X, so this is my X, that means all the sensor data, and this is my Y, that means my target column. Okay, now we can apply the test split operation. So this is the code you can apply. So here I'm using test split function. Inside that I'm giving my X data and Y data, and test size I'm specifying. I need actually 10% data for my testing and 90% data for my training example. Okay, and stratify Y I have given because you can see this is the it's an English character. Okay, so whenever you will give this data to the model, so it will convert to the number. Okay, then random state is equal to 1, and it will store your X data, Y test data, sorry, X train data, Y X train test data, Y train data, and Y test data. So let me execute. Now if you want to see the shape, so you can see this is your original shape, and this is your training example. You have 187 example, and in test you have 21 example only. Okay, now we can train the model. So just write model is equal to I can specify my logistic regression model. Inside that I will give my X train and Y underscore train data, and now we'll feed the data. Okay, so model dot feed X train and Y train. Okay, now if I feed okay, there is a error actually I'm getting. Okay, sorry guys, so the thing is like here you don't need to pass the data. Okay, so this is just a model initialization you are doing. Now here you are feeding the data. Now I think it should work. See, model got trained. Okay, now let's do the model evaluation. Okay, so what is the accuracy score you got after training the model? So what I can do, I can just first of all calculate the accuracy on the training data. So model.predict x train. Okay, I'm giving the x train because I want to see the accuracy on the training data, and you will see that training data accuracy would be always high because that same data we have used for the training. And to calculate the accuracy, guys, here you have to pass in the accuracy score function. So here I'm giving my prediction and I'm giving my original y train. Okay, now this will give you the accuracy. So let me print the accuracy here. Now see, here you are getting 83% accuracy. Okay, fine. Now you don't need to rely on the training accuracy, you also need to see the testing accuracy. Okay, if testing accuracy is good, then you can select the model. So let's calculate the accuracy on test data right now. So here I'm giving the test data and here I'm getting the prediction, and now I'll pass the test score inside my accuracy score. Okay, this one. So here I'm giving my prediction and my original y test. Okay, and this will give you, and this will give you your testing score. So first of all, let me execute this line, then I will paste this particular code, and this is my testing accuracy I'm getting. So it's almost 80%. So see guys, if you want, you can also perform some feature engineering on top of it to improve the accuracy. Okay, but I think this accuracy is also fine. Okay, you can use it. Now let's do one prediction on top of my new data. Okay, so what I will do, I will make a new data. So this is my input data, guys, I prepared. You can see this is the entire input data. So all the sensors I have collected, okay, one by one, all the 60 data. You can see it is having actually 60 record here. Okay, now first of all we have to convert this data to the numpy array. So you can see I'm converting to the numpy array. Then after that I have to reshape it. Okay, because here I only have one record, that's why I have to give 1 minus 1. Okay, so it will reshape the data. Then after that I will pass it to my model. So here you can see model.predict, and here I'm passing the data. Now it will give me the prediction. Now it's predicting m. Okay, if it is m, so I can write a condition here. So this is the condition. If prediction is equal to r, object is rock. If prediction is equal to, let's say, m, it's a mine. Okay, now if I execute, so it's a mine. Okay, because it is predicting m. So yes guys, we have completed this project. Now if you want, you can also improve the project. You can also add some more feature engineering technique, and if you want to convert it to the end-to-end pipeline, guys, I already shared the template with you. The same template you can use. Okay, I'm not going to show you again and again the same implementation, and you can deploy this project also. Okay, and I also showed you how we can create the user interface of your application. If you want, you can also create it. So yes guys, this is the project. In the next video we'll be creating another project. Okay, so that's how you will be getting lots of project idea, and this project you can mention in your resume as well. Okay, so with that guys, thank you so much for watching this video, and I will see you next time. Hi guys, in this video we'll be implementing another project called diabetics prediction using machine learning. So here we'll be using diabetics data. With the help of that, we'll be building one classification model, and that model will able to classify whether a patient is having diabetics or not. Okay, so I'll show you the data, how this data looks like, and where you will get the data, and everything I'll try to share. So guys, you can see this is the workflow of the project. So first of all, we have to get the diabetics data. After that, we have to perform some basic pre-processing steps. Then we'll be performing tensor split operation, and here the model I'm going to use called support vector machine classifier. So you can use any kinds of classification model, but I was trying with this model, and this model was working better. That's why I'll be picking up this support vector machine classifier. So once I train the model, what I will do, I will take this particular model, and whatever user will give the new data, I will pass to the model, and model will try to predict whether this person is having diabetics or not diabetics. Okay, so this is the entire system, guys, we'll try to develop. And again, if you want to implement this project as an end-to-end pipeline, I already showed you how to implement. You can easily convert it. So guys, you can see this is the data we'll be using. So you can see it is having some features like pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, okay, diabetics, pedigram function, then age. Based on that, we'll try to predict this particular outcome. 1 means he is having diabetics or she is having diabetics, and 0 means they don't have the diabetics. Okay, so it is already integer encoded, so we have to use the data. Even this data is already available in the Kaggle. So if you search like diabetics, okay, diabetics data Kaggle, so this is also available. You can see this is the data, guys. So you can see this is the data, diabetics data, and even it is also having the same features. So you can either download from this particular Kaggle, either you can use this particular data. I will share the link with you. Okay. So what I will do, guys, I will open up my Google Colab quickly, and there we'll try to connect and we'll try to uh, implement the entire project. So here let's get a new notebook. So here I will give the name diabetics prediction, and let's connect the notebook. So after that, let's import all the necessary libraries. So I'm going to import NumPy as np. Then I'm going to import pandas as pd. Then I need some functionality from the scikit-learn. So from scikit-learn, uh, preprocessing, I'll import standard scalar. So here we'll be performing the scaling technique. So standard scalar will try to import. Then I also need render speed. So from scikit-learn dot model selection, import render speed. Then I need the support vector machine classifier. So from scikit-learn dot or import svm. Okay. Then I need the classification metrics. So I'll be using accuracy score. So from scikit-learn dot metrics, import accuracy score. So let me import all of them. So it's done. Now here what I can do, I can upload the data I have downloaded. So let's upload. This is the data, guys. I'm going to upload here. So let's load this data. So to load the data, I'm going to use pd.read_csv, and inside that you have to give the location of the data. So copy path, and here just try to pass it, and let's store inside a variable. I'm going to name it as diabetics. Okay, diabetics underscore data. Now if I show you the head of the data, so you can see, guys, this is the data. So we have all the features. Based on that, we have to predict whether they are having diabetics or not. Okay. So now if you want to see like how many records you have, so simply just call this particular attribute called shape. So here you have 768 example and 9 columns. Okay. Now if you want to see some statistical report, so you can use the describe function. So describe, so it will give you the entire like description of your data, like what is the mean, what is the standard deviation, minimum value, maximum value, 25%, percentile, 50%, and 75%. Okay, you can see the entire report here. If you want to see the information of the data, so you can call the info function. So this will give you the data type, how much let's say memory it is taking. So everything it will give you. See here I am having integer and float data types. Okay. Now I want to see like how many, let's say diabetics and how many non-diabetics patients I'm having here. So for this, let's copy the name, and here I'm going to write diabetics. Okay, diabetics data. Inside that I'm going to pass this outcome, and I will just write value counts. Okay, so this will list down. See, so non-diabetics person you are having 500, and diabetics person you are having, okay, 268. And if you want to see the mean of this outcome with respect to all the, let's say, features you have, so what you can do, you can simply call the data diabetics data. You can perform the group by operation. So group by, so here I'm going to pass the outcome, because this is going to be my target column. Okay, I want to see the outcome. So mean, so I'll get the mean. Now if I execute, now see, guys, this is the outcome. That means non-diabetics and diabetics, with respect to that, this is the mean. Okay, this is the mean. So you can see the pregnancies mean. You can see, guys, those who are having diabetics, so this is the like number. So that means most of the person are pregnant, and glucose level is also high. Then blood pressure is also high. Skin thickness is also high. Insulin is also high. BMI is also high, and diabetics pedigree function is also high, and age is also high. That means everything is high. Okay, if everything is high, that means this person is having more probability, okay, having diabetics. I think now you got it, okay, from this particular analysis what this data is trying to say. All right, now let's try to separate out my x features and y features. So this is going to be my x features and this is going to be my y features. So let's do it. So for this I'm going to take my x variable and I'll call my data diabetics data, and I'm going to drop the outcome. So columns, I'm going to drop the outcome columns, and this is a column, so that's why axis should be 1. So axis is 1, and I'm going to take the y data right now. So diabetics. So here I'm going to take the outcome only. Now if I show you, so this is my x and this is my y. Now you can see guys, this scale is different. Now I will be applying the standard scaler so that I can bring all this number in the same scale. Okay, so let's initialize my standard scalar. I already imported, I think, remember. So scalar is equal to standard scalar. So let's create an object now. Scalar, I'm going to fit my data. So fit, I'm going to fit my x data. Okay, so it's done. Now let's do the transform. So scalar dot transform, again pass the x data, and this will give you your standardized data. Okay, now if you want to see that, so simply call that. So now you can see guys, we have converted all the data in the same scale. Fine. Now let's again store this data in my x variable. So standardized data, and y is equal to my outcome. Okay, now let me store them. Okay, so here diabetics, it should be data, not data sets. Okay. Okay, so it's working fine. Now let's apply the train test split operation. So I think, remember guys, we use this particular code snippet to perform the train test split. So we are giving the x and y, and test size is equal to 0.2. That means 20% data I'm keeping for the testing and 80% I'm using for the training. So now let's convert. Split them into train test split. Now what I will do guys, if I show you the shapes, so this is my original shapes, this is my train, and this is my test. You can see, okay, training I got 614, and test I got 158, sorry, 54, and this is my original one. Okay, now let's like train the model. So to train the model guys, I have to do the classifier dot fit operation. So now let's train the model guys. So first of all, let's initialize my classifier. So here you can see guys, I'm using support vector machine classifier, and the kernel I'm using linear kernel. Okay, if you go to the like documentation of support vector, you will see that it is having different kernel. So I'm using the linear one. So this is going to be my classifier. Okay, now let's feed the data. So you can see I'm feeding my x10 and y10. Now let's train the model. Then after that we'll do the evaluation. And again guys, we can do the evaluation, I think, remember, on the training data as well as the test data both. So first of all, I'm like calculating my training accuracy score. So this will give you the prediction, and this prediction I'm checking with the help of accuracy score. This will give you the training accuracy. So let me print the training accuracy. So this is my training accuracy guys, I'm getting 78%. Now let's also calculate the accuracy on top of my test data. So here you can see I'm giving the test data. Now whatever score I'm getting, I'm just comparing with my original one, and this is going to be my test score. So let me show the test score also. So here I'm getting 77. That means it is close to training. That means this model is fine. Okay, there is no let's say overfitting problem, okay, or underfitting problem. Now let's do the single prediction guys. Okay, so let's say this is my input. So here I have all the parameter like insulin, then blood pressure. Okay, all the parameter I have taken with all the value. Now I will first of all convert it to the numpy array. Okay, because sklearn support numpy. Then I will reshape, because here I only have one example. Okay, that's why I'm reshaping. Then after that I will do the transform operation, because I have to also convert it to the scaling, okay, because we also applied the scaling in the training data, so I have to also apply the scaling technique on the user data. Then after that we'll try to predict. So here is the prediction. So here model will try to predict and this will print the prediction. So let me show you. It's predicting as 1. 1 means this person is having diabetics. So here I can write a condition. So if my prediction is 0, that means this person is having no diabetics, otherwise this person is having diabetics. Now if I execute, see, this person is having diabetics because it's predicting as 1. Okay, now you can change the number and you can again do the predict. You will see that this prediction would be different. Okay, so yes guys, so this is the project diabetics prediction, and now if you want you can convert it this thing as an end-to-end pipeline by referring my same template. With that guys, thank you so much for watching this video and I will see you next time. So guys, now we'll see one demo of this DVC. We'll try to build and track one ML pipelines with the help of DVC. So first of all, I will show you the notebook. Whenever, let's say, you develop any kinds of, let's say, project in your traditional way, what you usually do, you use something called Jupyter Notebook, right? So I have already prepared one project in a Jupyter Notebook. So what I will try to do, I'll try to convert this notebook to the pipeline. That means we'll be creating different component. Okay, so I think it would be better if I show you practically everything, then you will be able to understand. So let's open up our directory, and there let's create one folder. Inside that I will show you the entire practical demo. So guys, I have opened up my local folder. So inside that I'm going to create a folder. I'll just name it as ML pipelines using DVC. And inside that what I will do, I will open up my terminal. Okay, so in case, actually, you can also open up your Anaconda prompt. Just search for Anaconda. So guys, I'm expecting you have the Anaconda in your system. If you don't have, just try to install the Anaconda. And apart from Anaconda, you need Visual Code Studio, Microsoft Visual Code Studio. Just search on Google and try to download and install by doing the next. Okay, the way you install any kinds of software, you can do it. So here you can see I also have my Anaconda. Even I also have my bash terminal. Okay, this is the git bash terminal. So what I did, I integrated my Anaconda with my git bash terminal. Okay, so you can directly also launch up your Anaconda. Okay, with the help of that you can also run all the command. Okay, so here I'm going to open up my bash terminal. Okay, so here the first thing what I will do, I will open up my Visual Code Studio. So to open up the Visual Code Studio, what you can do, just right click, show mode option, and there is a option called open code here. Okay, either what you can do, you can open up your terminal and just write code space dot. So if you just execute this command, it will automatically open the VS Code in this particular directory. So what I'll do, I'll open it like that. So you can see this is my Visual Code Studio. So let me zoom. Fine. Now guys, here the first thing what you have to do, you have to set up the environment. See, every time whenever we are creating any kinds of project, we have to create the virtual environment. Okay, so this is recommended. So to create the virtual environment, what are the commands you have to run? So let me show you. So I already prepared all the command for you. So guys, as you can see, I already created this readme file, and inside that I already mentioned all of the command you need going forward. Okay, so here inside how to run actually section, you will see how to create the virtual environment. So this is the command you have to execute, conda create -n. You can give your environment name. In case I have given test, you can give any other name, it's up to you. Then Python 3.11 okay, -y. Then after that you have to activate the environment, then you have to install the requirements. Okay, now you can see inside requirement.txt I have mentioned all of the requirement package. Okay, like I will be using scikit-learn, XGBoost, okay, NLTK, pandas, numpy, DVC and PyYAML. And if I want to install DVC guys, it's like very easy. Only just write DVC in the requirement.txt and just execute this command, pip install -r requirement.txt. It will automatically install DVC from PyPy website. Okay, either you can also open up your terminal and you can just write pip install DVC. Okay, that's how you can also do it. So that's why DVC is like very popular, because it's easy to set up. You don't need to do so many configuration. And I already told you to execute the DVC, you need the Git. Okay, Git running in your, let's say, directory. So first of all, we have to initialize the Git. So that's why we have mentioned this command. Okay, Git initialize. So first of all, what I'll do, I already created my environment. So let me activate. But for you, if you don't have the environment guys, please try to execute the first line of command. So I'll execute the second line because I already have the environment in my system. So let me show you. So conda activate test. Okay, see, test is already available. Okay, now what you have to do, you have to install this pip install -r requirement.txt command. So it will install all the requirements in your environment. See, for me it is satisfied because I have already installed all the requirements, okay, in my operating system. Now, once you have set up everything, guys, so try to open up this notebook. Okay, you can see inside notebook folder, I kept one notebook. So this is the notebook, guys. And I'm expecting you are already familiar with, guys, basics of machine learning. Okay, so these are the thing I think you are already familiar with. So here I'm not going to, let's say, write this code from scratch, because this kinds of project you have already implemented, okay, in your previous days in your Jupyter notebook. Okay, I already prepared one notebook, you can see. So the notebook name is Twitter emotion detection. So what I am doing, I have one data, actually, you can see inside my GitHub. So let me show you the data. So this is the URL of the data. Okay, you can see this is the Twitter data. So it is having actually different tweet. Okay, with respect to that, it is having the sentiment, whether this tweet is a, let's say, sadness tweet, or whether it's a, let's say, neutral, whether it's a, let's say, happiness. Okay, so these kinds of label actually it is having. This is the Twitter ID, this is the sentiment, this is the content, you can see. Okay, so this data is available inside this URL, okay, inside my GitHub URL. So what I will do, so what I've done, first of all, I'm ingesting the data from the URL itself. Okay, so that's why this is called actually data ingestion. Actually, let's say section. Okay, I have labeled like a data ingestion section. So as of now, everything we are doing in our Jupyter notebook. Later on, I will show you how we can create the pipeline. Okay, that means different component. So as of now, we are following our traditional approach. So for this, what I've done, I have imported all the library, you can see, like scikit-learn. Okay, so you can see NLTK, because this is a text data, right? So if I want to, let's say, do the preprocessing, so I need these are the NLTK library. I think you already know. Then count vectorizer I need for the feature creation. Then you can see I'm importing all the necessary library. Then after that, what I'm doing, I'm reading the dataset from the URL, okay, with the help of pandas, and that's how your dataset looks like. Then after that, you can see I'm dropping this column tweet ID, because this is not required. Okay, tweet ID is not required. Then after that, this is the final data. Then once it is done, what I'm doing, instead of taking the 3 label, that means sadness, happiness, and neutral, I'm only taking 2 label. Okay, as of now, just to simplify the project, I'm taking happiness and sadness. Okay, you can see from the entire sentiment, I'm filtering this to like sentiment. Then after that, this is my final data. Then once it is done, I'm you can see this is a like a category, right? This is a text, so I have to convert it to the number. So here I'm replacing happiness with 1 and sadness with 0. Okay, then you can see this is the data. Then I'm doing the 10 test split operation. So let's say, as of now, let's consider this is my data ingestion. Okay, this is my data ingestion, let's say, part I have done. Then let's do the data preprocessing, because I think you know the entire machine learning life cycle, right? I already showed you one graph in my introduction session. So there, first of all, we take the data, we do the EDA feature engineering, okay, data preprocessing. So these are the steps actually we are following one by one. Now these are the preprocessing steps. So I'm using lemmatization, remove stop word, removing numbers, lower casing, okay, removable punctuation, then removing URL, okay, then you can say normalize the text, then normalize the sentence. So I think you already know, okay, these are the preprocessing steps we perform usually on top of the text data with the help of NLTK library. So what I've done, I've created actually different function, you can see, okay, for this. Then let's say this is the demo. I have given one text, and this is the final output, okay, after preprocessing my data. So what I'm doing, I'm applying on top of my entire training data and testing data. Now your data set is ready. Now I'm doing the feature engineering, the next stage. Okay, now inside feature engineering, what I'm doing, I'm doing the counter vectorizer operations. It will give me the entire numerical representation of your data. Okay, then after that, I'm building one model. I'm using the XGBoost model. You can see XGBoost classifier, because this is the classification problem statement. And you can see I'm building the model. After building the model, you can see I'm doing the evaluation, and this is the evaluation score. Okay, so as of now, let's try to consider this is the project we have developed in our traditional way, Twitter emotion detection. Okay, so you can also let's say improve this project, but as of now, improvement is not my main intention. I need to show you the pipeline, and I need to show you how we can track the pipeline with the help of DVC. Okay, so going forward, whenever we'll be implementing like end-to-end project, that time I will show you, okay, the entire notebook process and all. So as of now, let's consider this is the project we have developed. Okay, now you can execute from your end. If you want, you can select your let's say environment. Let's say I created one environment called test. You can select and you can execute all the cell one by one, but I'm not going to execute because I'm expecting already familiar with. Okay, that's why I've given you the walkthrough of the code. Now this is your traditional approach to implement one project. But I already told you, if you are following this particular approach, so this is not an efficient way. That means here you are losing the modularity. Okay, that means you are writing the code everything in one place, so here you are losing the modularity. So one problem you'll be getting here, like code management. Then if you're let's say collaborating with different team, so collaboration you can't do. You can't actually add new features in an easy way. So that means the entire code problem you'll be getting here. Okay, and how to solve it? we have to follow the modular coding. Okay, so as of now I'll show you the simple modular coding, but going forward we'll be also writing the like complex modular coding. Will be using Python OP concept, but as of now I'll be using the functional concept. Okay, now how we can improve this project, guys? Okay, I think you have to follow the modular coding. So to follow the modular coding, what I have done, I created actually different module. Just let me show you. So guys, as you can see here, I have created one src folder. Inside that, I have created different component. You can see data ingestion component, data preprocessing, feature engineering, model building, and model evaluation. Now see the same code. Okay, the same code I have copy pasted inside this particular file itself. So let's open up this data ingestion.py. So here you can see I have imported all the necessary library for the data ingestion, and additional thing I have added the login functionality. Okay, you can also log the, let's say, message. Let's say if some error is going on, you can log it, okay, in a file. So later on I will also discuss this logging in detail. As of now, just consider this is a login. That means if any error is occurring, I'm logging in a file, okay, instead of printing in my terminal. So that's how you can do the log configuration. And you can see here I have written in a function, okay, like load data. How to load data from the data URL. That URL actually I'm providing GitHub URL. After that, preprocessing. Preprocessing means it will let's say take the tweet, drop the tweet ID. It will take only happiness and sadness. Then it will replace with 1 and 0. Okay, the same thing. I think guys, you remember the same thing we are doing now here. Same thing I have written inside the function only. Then after that, I'm saving the data, okay, in a folder. I'm creating a data folder. Inside that a raw folder. Inside that I'm saving as a train CSV and test CSV. Very easy code, guys. Very easy code. If you go through this code, very easy. Okay, there is nothing complex I have written. And here inside main function I'm executing. First of all, I'm loading the data. I'm preprocessing. I'm calling the preprocessing function. Then I'm calling the train test split. Okay, train test split. Then after that, I'm saving all the data. Okay, with the help of this save function. So once everything is done, I'm calling this main function. Okay, here. That means my entire code will be executed. Okay. Now you can test whether it's running or not. So what I can do, I can open up my terminal and let's execute the data ingestion.py only. So this is the command Python. Folder is available inside src. Okay, data ingestion.py. Now see if I execute, it should run. So guys, as you can see, my execution is completed. Now you can see it has created one data folder. Inside that raw folder and my train data as well as the test data is saved. Okay, that means this particular pipeline is working fine. Okay, this is called pipeline. Okay, we have created one pipeline. Okay, you can call it as component or pipeline. Okay, now instead of writing in a like Jupyter notebook file, what I have done, I've created a Python file, and inside that I have separated this particular data ingestion step. Okay, this is called pipeline, and this is the first pipeline. Okay, data ingestion pipeline. Now let's see the data preprocessing pipeline. Okay, so again, if you open the notebook, so I think you remember we also did the data preprocessing. So here what we did, guys, yeah, so this is the data preprocessing. So here I did the like lemmatization, stopword, removal, lower casing. Okay, so inside that also you can see I'm written the same thing, okay, in a function. Okay, the same code I have just copy pasted here. And here you can see if all of the function executed, I'm saving the data in another folder called processed folder inside data. And here I'm saving the data. Okay, you can see to a CSV file. Now again, let's try to execute and try to see. So I'll open up my terminal and here I'm going to execute data preprocessing. Okay, .py. Now see, executed. Now if I open the data folder, you can see processed folder has created. Inside that, this is my processed data. Okay, that means after performing all pre-processing, this is the final data I got. Now the next component I created, feature engineering. I think you remember we also have the feature engineering step here. Okay, inside feature engineering, what I was doing, I was applying the counter vectorizer to create actually numerical features. Okay, now you can see I'm doing the same thing. I'm using the counter vectorizer. I'm loading the data. Okay, that means my preprocessed data from the directory. After that, actually I'm doing the counter vectorizer operation. Okay, and once it is done, I'm saving again inside a directory called features. Okay, inside data folder. Now let me show you. So if I open up my terminal and let's execute. So I'll just write Python src feature engineering.py. Done. Now if I show you, see feature C. So this is my featured data. Okay, you can see all the numerical representation data. Now once feature engineering is done, the next was my model building. So again I created a model building.py. Okay, now you can see here I'm creating the model. So now you can see inside model building I'm training the entire model and I'm saving the model in a pickle format. Okay, now let's try to show you how it will work. So again I will execute
model building. So it will train the model and it will save. Okay, you can see model.pkl has been saved. Okay, then once model building is done, I was doing the model evaluation. That means I was calculating all the accuracy, precision, recall accuracy. So here I've created another component. You can see model evaluation. I'm loading the model, loading the data, and with respect to that, I'm calculating all this code and saving as a JSON format. Okay, now let me execute and let me show you. So here I can write Python src model evaluation by done. You can see this is the metric.json, and inside that all the accuracy has been saved. Okay, now guys, here we have created a simple pipeline. Okay, going forward we'll be also creating actually complex pipeline, and I'll be using the modular coding advanced modular coding, like we'll be using class. Okay, object oriented programming concept. Okay, but this is the simple pipeline as of now we have created, because we are just entering into our MLOps practical, right? So at the very initial phase, I don't want to take the complex pipeline. That's why I've taken the easy pipeline. Now you can see this is my pipeline. Okay, now just try to consider to execute this particular project. That means the Twitter sentiment project. So I have to execute all of the component. First of all, data ingestion will happen. So this is going to be my first stage. Then data preprocessing, second stage. Feature engineering, third stage, model building, fourth stage, and evaluation, fifth stage. That means it has to follow one step. Okay, and this is called actually pipeline. First of all, this pipeline, this pipeline, this pipeline, this pipe, this pipe. That's how it has to execute. Okay, one by one. It's not like that you have executed the data ingestion, then your model evaluation is running. No, after data ingestion, preprocessing is required. Preprocessing needs the feature engineering. And feature engineering needs the preprocess data. Okay, model building need the feature engineering data. Then model evaluation needs the model. Okay, model building. That's how it is depending upon each other. Okay, that means your pipeline is depending upon each other. Okay, this is called actually pipeline, ML pipeline. Got it? So as of now, whatever project you have developed in a notebook, so this is the experiment. This is the experiment you are doing inside notebook. That means you are checking whether everything is working or not. But whenever you are implementing for the production, you have to follow this particular modular approach. You have to create separate component and you have to build the entire pipeline. Okay, now how we can execute this pipeline with the help of DVC, we have to learn, because here we are learning how to build the ML pipeline and how to track the ML pipeline with the help of DVC. So to use the DVC, guys, I think we have already installed DVC here inside requirements. So here you have to create one file called dvc.yaml. Okay, dvc.yaml file you have to create. So guys, to create the dvc.yaml file, you can right click and create a new file and just write dvc.yaml. Okay, so I already showed you the DVC documentation there. They have also suggested if you want to use DVC, you have to create this dvc.yaml file. Now you can ask me why YAML file, why actually not any other file format? Because see, inside MLOps and DevOps, most of the configuration file they use called YAML. Okay, so YAML, I think you know the YAML full meaning. So if you don't know, just go to Google and search YAML full form. Okay, so yet another markup language. Okay, so this is the full form of YAML, and this is the most used file format in the DevOps and MLOps for all the configuration. Okay, whether you are doing for DVC configuration, Kubeflow for configuration, okay, or any other, let's say, software configuration, people are using YAML file format because it is more easy to write and more easy to understand. Okay, so first of all, let's try to delete all the output I have generated, because I'm going to generate this output with the help of DVC. Okay, so here let me delete everything. I'll delete the data, then I will also delete this log file. Let me delete the log file, then I will also delete this metrics and model. Now everything is set. Now we have to write the DVC commands. Okay, now how to write the DVC commands, I will show you one example. Okay, and after seeing this example, you can create any kinds of DVC command. Okay, any kinds of, let's say, pipeline you are using, you will be able to write the DVC command. Okay, so first of all, you have to write for the data ingestion, because you can see the first pipeline is my data ingestion. Okay, now if I want to execute with the help of DVC, so what I have to do, I have to create a stage, actually different stage inside DVC. It is called stage. Okay, so this is the first stage, second stage, third stage, fourth stage, fifth stage. Okay, so first stage is data ingestion. So that's how your stage would be look like. So let me show you guys here. So first of all, you have to write the stage, then you have to give the clone symbol, then inside that you have to give the data ingestion. You can give any name. Okay, here I have given data ingestion. Okay, this stage is data ingestion. And what is the command if I want to execute the data ingestion.py? I think just before I showed you Python data ingestion.py. This is the command you have to write inside cmd. Okay, cmd, let's say keyword. Now to execute this, let's say file, what is the dependency? Okay, dependency, definitely this file is a dependency. Let's say if this file is missing, then which file it will execute? Definitely this file is a dependency. So here I have written src/data ingestion.py, because inside src folder this data ingestion py is present. That's why it is the dependency. And after executing this let's say pipeline, what would be the output? Output would be my data/raw. That means I think you remember it was creating a data folder inside that raw folder. Okay, and inside raw folder it was ingesting my data. Okay, so this is the DVC command. Very easy guys, very easy. And that's how your YAML commands look like. Okay, that's why people use YAML for the configuration. Now let me execute and let me show you how it can be executed with the help of DVC. For this you have to follow, these are the DVC commands. So first of all you have to initialize the Git, because I already told you DVC runs on Git. So let's copy this git init command and open up your terminal, and first of all initialize the Git here. So guys, you can see successfully we have initialized the Git. Okay, and to initialize the Git guys, you need one software called git bash. And how to install this git bash? Just write git scm, okay, in the Google. So this is the first website. So here you can download this particular software and install by doing the next and try to install. After that you will see this particular git bash. Okay, git bash. Okay, so this thing actually you need. So if you don't have the git bash, so you can't execute any kinds of git command. Okay, I think I already showed you the Git. Okay, Git series actually of the version controlling. I already showed you how to install Git and how to configure the GitHub. Each and everything I already discussed. Okay, so here I'm not going to show everything from scratch. So you can see guys, I have initialized the Git. Okay, Git has been initialized. Then once Git has initialized, the next thing you have to initialize the DVC. Okay, and to how to initialize DVC, you have to execute this command DVC init. So let's copy and execute. So guys, you can see my DVC has been also initialized. Okay, and how you will get to know? So here you will see .dvc folder. Inside that you can see some certain file. Okay, so with the help of these are the file, it will track, okay, your pipeline. So you can see successfully my DVC has been initialized, and it will also create a DVC ignore. Okay, DVC ignore, it is similar kinds of your git ignore. Okay, git ignore, like let's say ignore anything. So DVC ignore, you can also mention, let's say which file you want to ignore. Okay, you can also mention this thing here. So as of now it's not required. Okay, great. Now everything is set. Now the next command, you have to run the DVC repro, and this is the final command. Okay, if you execute this DVC repro, what will happen? It will look for this dvc.yaml file. Okay, and inside dvc.yaml file, whatever command you have mentioned, it will execute. Okay, so what is the command we have executed? Mentioned inside dvc.yaml, I have mentioned this command. It will execute my data ingestion pipeline. Okay, and after executing this pipeline, what will happen? It will ingest the data from the URL itself. So let me show you. So if I copy and if I just execute DVC repro, see what will happen. Okay guys, so the error is it is not able to find this directory because if you see, I have done one mistake here. So it should be command, okay, but here I have given the directory. So here I have to remove this slash. Now see, it's fine. Okay, because Python is a command and I'm executing this file in this directory, src directory. Okay, so this was my mistake guys, sorry. So now let me save, and again let me run this DVC repro command. Now see, this first pipeline is running. Okay, it is ingesting the data. Now see, data ingestion done. Now you can see it has created the data folder, inside that the raw, and you can see the data has been ingested. Okay, now everything you have executed, now with the help of DVC repro command, it has tracked in the dvc.log file. You can see, okay, all the, let's say version, the time, okay, everything it has saved here. Even the size of the data, everything it has saved here. Okay, so now what is the advantage? Now see, if I'm running if I'm executing this command second time, it won't be running. That means it won't be let's say ingest the data from the URL, because this data is already present inside my directory. See, let me show you. It will tell data ingestion didn't change, is keeping. Okay, that means everything is up to date. That means this pipeline didn't change. That means you haven't changed this particular code, or let's say you haven't changed the data. Okay, that's why this pipeline won't be executed. I think I already showed you, okay, why pipeline tracking is important, because at the end, if you are running this pipeline in the production environment, it has cost involvement. Okay, because everything you are running in the cloud, so every time you don't need to, let's say, run the same pipeline again and again if there is no change of your, let's say, feature or let's say data. Okay, so that's how with the help of DVC we can track. Okay, we can track our pipeline. This is the main advantage. Now let me show you if anything is changing in the data, this pipeline will execute. Okay, so let me show you. So what I'll do, I'll in the data ingestion, so instead of taking this happiness, so what I can do, I can take the neutral. So let me load the data first of all. So inside sentiment you see I think not here. What I can do, I can open the URL. That would be better. So this is the URL. So here we have one label called neutral. Okay, so let me copy, and here instead of taking happiness, I'll take the neutral. Okay, neutral I will assign as 1. Let me save. Anywhere happiness is there, let me check. No, I think happiness is not there. Now see, I have changed this pipeline. Okay, I have changed inside this pipeline. Now see, again if I execute this DVC repro command, it will remember my previous execution and it will check the current code as well. If any change is there, definitely it will execute that pipeline. Let me show you. See, if I executing, see, it is again running. Okay, why? Because I have changed inside my pipeline. Okay, now see, ingestion is done. Okay, now if I show the data again, now see, it is using the neutral. Okay, instead of using the happiness. So what I'll do, I'll go back. I think happiness is fine. Then again, let's execute. Done. Okay, so that's how, guys, it remembers. Okay, it remembers your execution. Okay, it remembers your pipeline execution. Okay, and that is the advantage of DVC. Okay, with the help of that, you can create the entire pipeline and you can track it as well. Now let's try to complete for all the pipeline one by one inside this DVC YAML. Okay, I will add all the commands. So here I'll add the next command, next for the data preprocessing. So that's how you can write the data preprocessing. See, so name is data preprocessing. Inside that I'm executing this Python src data preprocessing.py, and dependency is you can see if I want to run the data preprocessing, what I need, definitely I need the raw data, the data I have ingested, because if I show you the data preprocessing, it is loading this data. Okay, that's why here I've given the dependency wise data/raw, because this folder is a dependency. If this folder is missing, my this pipeline won't be running. And again, this file itself would be the dependency, because if this file is missing, then which file it will execute, right? Then what will be the output? Output would be data/process. That means it will create a process folder. Inside that it will save all the processed data. I think I showed you one by one. Okay, so it's done. Now simply what I can do, I can execute again this repro command. See, data ingestion didn't change, so that's why it is skipping. Now it has executed the next one, data preprocessing. Okay, now if I show you, see, process has been created. Now if I'm again executing, it won't be running. See, everything is skipping. Okay, now let's add the next one, feature engineering. So this is what your feature engineering. Guys, I think you got it. Okay, how to create these commands. Okay, very easy. You just need to understand your pipeline. Okay, what is the input, what is the output? Okay, you just need to understand the dependency as well as the output. If you understand, you can create any kinds of, let's say, DVC pipeline. Now this is for the feature engineering. Name is feature engineering, command is Python src feature engineering.py. Dependency would be definitely the process folder, because this feature engineering need the process data and this file itself, feature engineering file itself. And what will be the output? Output would be data.features. I think you remember, it will create a feature folder. Inside that it will save all the features. Okay, now let me save, and again let me execute. See, this two stages has skipped because it didn't change, and it has run the third pipeline. Okay, which is nothing but my feature engineering. Now you can see feature has created. Okay, now let's add this one, model building and evaluation. So I'll add quickly. So this is my model building. Okay, now you can see this is the command model building.py. Dependency should be the feature. Okay, and as well as this file itself, and it will output model.pkl. Okay, fine. Now let me execute it again. See, this 3 pipeline is skipped and only model building has run, and this is the model it has created. Okay, now let's add the evaluation as well. So this is what your evaluation. Okay, now again you can see name is evaluation, this is the command, and this is the dependency. Model should be a dependency, and evaluation.py. Okay, this should be a dependency, and it will generate a matrix. I think you remember matrix.json, because if I show you, it will create a matrix.json. Okay, and if you are getting any kinds of matrix as an output, okay, that time you can mention inside matrix. Okay, why? Because inside DVC we have one commands. Okay, DVC matrix show. So if you execute this command, it will show you all of your matrix. Okay, so that's why you have to add inside matrix. Okay, matrix.json. Now let me show you. So if I execute it, DVC repro, now see evaluation is running, and this is the matrix.json I got. Okay, now if I again execute this DVC repro, what will happen? It will skip everything, because all the pipeline has executed and there is no change. Okay, but let's say if you're not using DVC, if you're executing these at the pipeline, okay, all of them with the help of Python code, what will happen? Every time whenever you will execute, it will execute all of the pipeline one by one every time. And again, it has the cost involvement. Let's say we're doing a deep learning project. Definitely training deep learning model is very cost, right? It needs GPU and all. That's why whenever you are creating any pipeline and whenever you are executing retraining, add the DVC with that, so that it can track the entire pipeline. Okay, I hope you are clear. Okay, why it is so important. Now let me show you some more commands. If you want to see the let's say your pipeline, okay, pipeline dependency, you can execute this command DVC DAG. It will show you one diagram. So if I execute, see, this is how your pipeline looks like. Okay, you can see data ingestion, data preprocessing, feature engineering, model building, and evaluation. You can see all the pipeline is connected with each other. So data ingestion is connected with data preprocessing, because data preprocessing need the data ingestion. You can see this is connected. Then feature engineering need the data preprocessing, it is connected. Then model building need the feature engineering, it is connected. And model evaluation need the model building, it is connected. That means it's a linear pipeline we have created. Okay, so this is how your let's say DVC helps us, okay, to create the entire pipeline and to track the pipeline. And there is another thing I want to show you. So this matrix command, if you want to see the matrix, so you can execute this command DVC matrix show. Now if I execute, see, it will show all of the metrics, okay, like your accuracy, precision, and recall. Okay, you can see from the matrix.json itself. Got it? So that's why we have added this matrix inside this particular matrix parameter. Got it, guys? So yes, this is the demo of the DVC, and that's how we can create the pipeline and you can track the pipeline. Okay, and going forward, we'll use this concept whenever we'll be implementing the end-to-end project. Okay, so that time I will use this DVC to track the entire pipeline, okay, of our development. So yes, guys, this is all about of this DVC. I hope you got it. Now what you can do, pick up any kinds of other dataset and try to follow the same concept and try to use the DVC. Unless and until you are not practicing, things would be more difficult. Please try to practice, try to implement from your side. Definitely the concept would be more clear. And all the resources I will share in the resources section. From there you can download. With that, guys, thank you so much, and I will see you in the next concept.
Hi guys, welcome to the project. So guys, in this video we'll be implementing another amazing project with the help of machine learning called fake news prediction. So in this project, guys, we'll be using textual data. So again, this would be one amazing experience because so far we have worked with the numerical data. Now we'll be also working with the textual data. So if you have the text data, how we can convert it to the numbers, everything we'll try to learn. So guys, the dataset actually I'm going to use, the dataset is already available over the Kaggle. So let me show you the data. So guys, you can see this is the data we'll be using, and this data is available over the Kaggle website called fake news. And here is the data. So it has training.csv, test.csv. So here we'll be downloading the train.csv and we'll try to do the analysis on top of it. So what you can do, I'll share the link. From there you can download. So there is a download button. If you click here, so it will download the zip file. Okay, so now let me show you the project workflow, like how we're gonna make the project, then we'll try to start the implementation. Guys, as you can see, this is the workflow of the project. So first of all, here what we have to do, we have to take the news data, and after that we'll be performing some basics preprocessing step, like you know that this is a textual data, and we have to do some preprocessing, like we have to do some preprocessing like is a stopword removal, lemmatization, right, lower casing operation. Then we have to also convert this data to the numerical representation. Then we'll be doing the trend test split to perform the model training, and here we'll be training one amazing model called logistic regression. And logistic regression is a classification model. With the help of that you can do the classification training, but I was trying with logistic regression, it was giving me good accuracy. So once we train the model, what we have to do, we have to give the new data, and this will take the model, and model will try to predict whether this particular, let's say, news is a fake news or real news. Okay, so this is the entire workflow. So now what I will do, I will open up my Google Colab and there we'll try to start the implementation. So to open up the Google Colab, just search for colab.research.google.com, and here click on new notebook. So here I'm going to name it as fake news prediction, and let's connect the notebook. So the first thing, I'm going to upload the data. So it is available in my download folder. So let me show you. So this is the data, train.csv zip. So let me upload it. I can drag and drop. Now you can see it is uploading. So once it is uploaded, I will import all the necessary library, then we'll try to load the data. So data is uploaded. Now let's import all the necessary library. First of all, I'm going to import numpy as np. Then I need pandas. Then I also need something called regular expression. So from import rd. Then I also need NLTK library, because inside NLTK we have all the, like, let's say text pre-processing functionality, right? So let's import it. So NLTK dot corpus import stopwords. Then I need steaming. So from NLTK dot steam, I think. Inside that we have porter, and I'm going to import something called porter steamer. So porter steamer is the steamer technique, guys. Okay. You can also use lemmatization, but here we are doing the classification, so it will work fine. Then I also need TF-IDF vectorizer to perform the like vectorization operation. That means we'll try to convert our data to the numerical representation. So for this, let's import it. So it is available in the sklearn dot feature extraction dot text import TF-IDF vectorizer, this one. Then I need tensor split. So from sklearn dot model selection import train test split. Then I also need logistic regression. So from sklearn dot linear model, okay, import logistic regression. Then I also need the accuracy. So from sklearn dot matrices import accuracy. Now let me import all of them. Now guys, we have to download one functionality from the NLTK. So let's do it. So NLTK from import NLTK. So NLTK dot download. We have to download stopword, because we need the stopword going forward. So we have to download it first of all. Now let me download. Okay, so it downloads one zip file. In that all the stopword would be available. And if you want to see all the stopword, guys, so you can see that print stopword dot words. Here we are working on the English data, so I'll show you the English stopword. So English, if I execute, you'll see that these are the stopword, guys, okay, in the English. So now what I will do, we'll load the data. So to load the data, first of all, we have to unzip this particular file. So this is the command you can execute, unzip, and here you just give the location of the data. So unzip done. Now if I refresh, so see guys, train.csv is available. Now let me load it. So I'm going to use pandas to load that. So news dataset is equal to pt dot read csv
Inside that I'm going to pass my CSV data, and let's load it. Now if I want to show you the shape, so it is having 20,800 example and 5 columns. Okay, now if you want to see that, so let me show you also. So news dataset.head. So guys, this is the data. That's how your data looks like. So title, author, text, and label. So that means the news title, even the author name and the text. Okay, so in this analysis, what I will do, guys, I'm going to use the title and author name to do the classification. I'm not going to take the text data, because text data is a huge. If you see, like, it has lots of text, so it will take lots of time to pre-process. So that's why I'm just for simplicity, I'll take the title and author. Okay, with the help of that, we'll try to do the prediction. But if you want, you can also use the text data. You can combine all of them. Okay, and this is the label. So here 1 means this is the fake news, and 0 means this is not a fake news. Got it? So now first of all, let me check whether it is having missing value or not. So to check the missing value, just write is null, and if I do some operation, so it will list down. So you can see title is having missing value, author is having missing value, okay, and text is having missing value, because there is a possibility when they collected the data, so that time some of the title was missing, some of the author was missing, some of the text was missing. Okay, so here we have lots of example, like 20,000 examples, so maybe we can drop all the missing value. Okay, this is not required. So what you can do, guys, you can just do the fill any operation. Instead of dropping, I will just fill this missing value with a space. Okay, empty space. So here I'll just write news data is equal to news data dot fill in a. Okay, I'm going to fill with this space. Now if I execute, now it's done. Now if I again show you the missing value, so see, there is no missing value. Okay, now we'll try to merge the title and author together. So how to merge? So for this, let's create a new column. I'm going to name it as content, and now I'm going to merge it. So I need author, and I need this title, news dataset title. Okay, so I'm merging these two column together, so title and author. So this will give me the content. Now if I show you, now if you see that data.head, now see, guys, here we created one new column called content, and here we combine the title and author. I'm not going to use the text data, because I told you it is having lots of text, it will take lots of time to do the pre-process. Okay, now this would be my x data, that means input column, and this should be our output column label. Okay, so let's separate out. So x is equal to my news data. So here I'm going to drop my column label, and this is the axis 1. Okay, so then I'm going to take the y as well, level. Okay, so it should be axis, guys. So now here we'll be writing a preprocessing function. So here we'll try to do all kinds of preprocessing steps. So I already prepared the function, guys. Let me show you. So this is the function, guys, I prepared. So here, first of all, so here you can see, guys, we are doing the lower casing operation. We are splitting it. Then we are also removing the stop word. Okay. Then after that, we are also performing the streaming, and this is my pre-processed data. Okay. So now you can apply this function on top of your entire data. So let me show you. So I will apply on top of my entire content. Okay. So guys, it's complete. Now if you want to see the content, now you can see it is completely pre-processed. Okay, it's completely pre-processed. Now let's separate out my x and y,
So I need the content only, and here I need the label only. Okay, now if I show you my X, so this is my X only, and this is my Y. So now what we'll do, we'll try to like convert them to the numerical representation. Okay, so for this we'll be using TF-IDF vectorizer. So let me initialize TF-IDF vectorizer, and now I'm going to feed the data. So I'm going to feed my X data. Okay, then you have to also do the transform operation. So now let's do it. So this is my uh, numerical representation. So if you want to see that, you have to use the to array. Okay, to array function. I think it should be to array. Now you can see this is the representation of the vector. Okay, you can also use print function to see that. See, okay, this is the representation of the vector. Now what we'll do, we'll try to do the tentative split. So I think remember the same code we also use previously. So this is the tentative split. So here I'm giving my X and Y data, and only 20% data I'm keeping for the testing, and rest of the thing I'm using for the training. Okay, so let me do the tentative split. Now here we'll do the model initialization, logistic regression model. Now finally I'm going to feed the data, X train and Y train. Then we'll try to see the training accuracy. So I'll give my training data, and I will see the training accuracy first of all. So this is my training accuracy, 98%. Now let's see the testing accuracy also. This is my testing accuracy. So it is also close to training accuracy. That means this is one amazing model we have developed. So 97% actually accuracy we are getting. Now if you want to do the single prediction, guys, so what you can do, let's take a single data from my test data itself. So I'm taking this third number example, then I'll pass into my model, and my model will give the prediction. So it's 0. 0 means it's not a fake news, I think. So if I write a condition, so if it is 0, that means it's a real news, and otherwise it's a fake news. See, okay. Now you can give any other data, you can also try. So this is the entire project, guys. Now if you want to convert this project as an end-to-end pipeline, you can refer my previous implementation. I think I already showed you how to create the end-to-end pipeline. Okay, so you can feel free to create. So yes, guys, I hope you enjoyed the entire project. Now please try to at least convert this project as an end-to-end pipeline. All the experiment will remain same, only you have to create as a pipeline itself. With that, guys, thank you so much for watching this video, and I will see you next time. Hi guys, welcome to the project. In this video, we'll be implementing another amazing project with the help of machine learning called loan status prediction. So here we'll be using one amazing data, and this data is available over the Kaggle. So let me show you the data, guys. So this is the data we'll be using. So you can download from the Kaggle website. I can simply search for loan prediction, okay, and you will be getting the data, and from there you can download this particular data set. So I already downloaded the data. Now what I will do, guys, so here this is the workflow of the project. First of all, we'll be getting the loan data. After that, we'll be performing some pre-processing step. Then we'll be doing tentative split operation, and here we'll be training one machine learning model called support vector machine, and using the trained model we'll be giving the new data, and this will predict whether this loan has been approved or rejected. Okay, so guys, you can see this data is having different features like loan ID, gender, married, dependents, okay, educations. So based on that, you have to predict whether this person will be getting the loan or not. Okay, so this loan would be accepted or not. See, you can see different columns are there. So I'll show you whenever I will import the data in my Google Colab. That time I'll show you. So first of all, let me open up my Google Colab. So search for colab.research.google.com and create a new notebook here. Now I'm going to name it as loan status prediction, and let's connect the notebook. And what I will do, I will also upload the data. So I already downloaded the data, so let me upload it here. So upload. So this is the data, I'm going to upload it here. So guys, as you can see, everything is connected. Now first of all, let me unzip the data. So for this you can execute this command called unzip. And as I already showed you the flow, okay, flow of the project, like how we are going to develop the project. Previously we also implemented some of the project, so that's why I will go a little bit fast, because you know like what to do, okay, at the end. So now let me unzip. Okay, it's not working because you have to rename the file. Let's rename it to archive.zip only. Now it should work. Let's copy and give the path and let's unzip. Done. Now if I refresh, so you can see guys, this is the data. Okay, so again you can rename it because the name is not good, so I can give, let's say, plain.csv only. That is fine. So first of all, I have to import some necessary library, so let me import all of them. So these are the library I need, guys, so let me import. Then I will load the data. So let's load the data. So for this we'll be using pandas. So pd.read csv. Said that I'm going to pass my data location. Now let's load the data. Now if you want to see the shape of the data, so you can see here we have 614 example and 13 columns. And if you want to see the data, dot head. So you can see guys, this is the entire data. So here we have loan ID, gender, married, dependents, education, self-employed, okay, application, income. Then you can see loan amount. Based on that you have to predict loan status. Yes means this loan has been accepted, no means it is not accepted. Okay, so here we need to do some pre-processing step, because you can see some of the columns are category. You also need to convert them to the numbers. Okay, I'll show you okay how to do it. And if you want to see the like statistical analysis of the data, you can apply the describe function. So this is the entire statistical analysis, like count, then mean, standard deviation, minimum number, maximum number, and so on. So let's see first of all whether any missing value are there or not. So you can see guys, this data is having some missing value, like gender having missing value, depends having missing value, loan amount having also missing value, okay, credit history also having missing value. So let's try to handle all of them. So what I will do, I will drop all the missing value, okay, because here we have less amount of missing value. I can drop all of them. Then if I again show you, see there is no missing value right now in the data. Okay, now what I will do guys, I will try to replace our loan status with 0 and 1, because if you see it is yes and no, okay, y and n. So I don't need to take the like categorical you can say text. So what I will do, yes I will let's say represent with 1, and no I'll represent with 0. So how to do it? So here let's perform the operation. So here you can see guys, I'm replacing the loan status no with 0 and yes with 1, and place is equal to 2 I want to do it permanently. Now if I show you, it's done. So see now my updated data, see it has become 0 and 1. Okay, now if I show you the value count of dependents column, because it's a category, so it is having actually different category. Let me show you. See it is having dependent 0, 2, 1 and 3 plus. Okay, so dependent means like this person actually depends on like that many of people. Okay, I hope you got it. So here we have one like data called 3 plus. So this is become actually categorical data, but these are the numerical data. So what I have to do, I have to handle it also. So what I will do, this 3 plus I'll represent with 4. Okay, so wherever it will have the 3 plus, it will replace with 4. So for this you can execute this line of code. So it will replace the 3 plus with the 4 value. Now if I go into the value count, you will see that all the 3 plus has become 4 right now. Okay, now see, this is the completely integer data right now. I can use it. Now let's do some data visualization. That means we'll be performing some EDA. So first of all, let me plot this counter plot. So here I'm plotting this education with loan status. I want to see like if the person is educated, whether there is a possibility to accept the loan or not. Now see, this is the graph I got, guys. You can see this yellow is accepted and 0 means this is not accepted. And you can see most of the graduate got actually loan. Okay, you can see status is high here. And there, if they're not graduate, okay, there is a very less possibility they will be getting the loan. So again, you can get some insight from the data. So now let's plot another graph like married and loan status. I want to see whether married person is getting loan or not. So guys, you can see married person is getting a loan. Okay, so they are getting more loan than the unmarried person. Now what I will do, I think you saw in the data we have lots of this one categorical column. So we'll make them to the number representation. So let me show you. So you can see like gender, then married. So these are the thing I have to convert it to the number. So I have already written a code. So see, this one will convert all of the category to the number. Like married, no means 0, yes means 1. So okay, gender, 1 means male, 0 means female. Okay, that's how I have written a dictionary, and in the dictionary I have mapped all the value. Now if I apply, so all the like say data has become the number right now. So let me show you. Status dot hit. See, now everything is number. So I need to drop this loan ID because it is not required. Okay, apart from that everything is fine. Now let me separate out my x and y. So here I'm separating out my x and y, and I'm dropping the loan ID and loan status because this is my x variable. Now if I show you my x, now see, this is my input features. Okay, and if I show you the y, this is my output features. Okay, now what I will do, will perform the test split operation. So let's do it. Here I'm keeping only 10% data for the testing and rest of the data for the training. Now if I want to show you the shape, you can see this is the original shape, and after training, this is the example and this is the testing example. Now let's initialize our support vector machine classifier. So again I'm using kernel is equal to linear. Now we'll try to train the data. So guys, you can see my model got trained. Now what I will do, I will show the evaluation scores. So first of all, let's see my training accuracy. I'll pass my training data. So this is the training accuracy I got. And if I show you the testing accuracy right now, so you can see this is the testing accuracy. So it is good. 83% I'm getting. So now what you can do, you can do the prediction, and this part I will leave it to you because I showed you multiple time how to do the single level prediction and how to write that condition. So this should be one task, guys, from my side. Just try to write the prediction code from your side. So yes guys, this is the project we have developed. Now if you want to convert as end-to-end, I already shared you the end-to-end pipeline, how to create it and all. You can use the same template to convert this project as an end-to-end pipeline. With that, thank you so much for watching this video, and I will see you next time. Hi guys, welcome to this video. So guys, in this video we'll be implementing one project called car price prediction using machine learning. So this dataset is already available over the Kaggle website. The dataset name is vehicle data. So based on some features of the cars, we have to predict the price. Okay, so first of all, let me show you the data, how this data looks like. Then I'm going to discuss about the workflow. Then we'll try to start the implementation. So guys, this is the data like we'll be using, or vehicle data. And you can see like we have some features. Okay, like these are the features we have, like car name, year, selling price, okay, kilometer driven, fuel. So based on that we have to predict the car price. Okay, so first of all you have to download the data. To download the data, guys, what you can do, so just click here and download as a zip file. So it will download the data, then we'll unzip and we'll try to use it. So for this, let's open up our Google Colab, but before that let me show you the workflow. So this is the workflow, guys, we'll be following. So here we'll be using the card data, and after that we'll be performing some basics pre-processing steps. Then we'll split into training and testing example. Then we'll be training one linear and lasso regression model. After that, user will give a new data and this will predict the price of the card. Okay, so this is the entire workflow. So now let's open up our visual code. So now let's open up our code editor. So to open the code editor, just write colab.research.google.com and here just create a new notebook. So I'm going to name it as car price prediction and let's connect the notebook. So here let's upload our data. This is the data I'll try to upload and I have to unzip the file. So let's write the command unzip. Let's rename it first of all. Now let's copy the path and let's unzip it. Done. Now if you refresh, so here you can see guys, this is the data. So here you can see guys, you have multiple file, but we'll be using this card data.csv. Okay, inside that you have all the data. So now let's do it. So what I will do, I will first of all import some necessary library, like I need pandas, then I need so here I'm going to do some visualization. For this I need matplotlib, so import matplotlib dot pyplot as plt. Then I also need to import cbon, so import cbon as sns. Then I also need to import the tentative split, so from scikit-learn dot linear model import tentative split, I think it is under available model selection, model underscore selection. Then I'm going to import train test split, so train test split. Then I need linear and lasso, so from scikit-learn dot linear model. It's a regression problem statement because here we have to predict the price of the car. That's why we'll be using regression model. And I think you know linear regression is the regression model. So let me import linear regression. Then I also need to import the lasso. It is also under available. It is also available under linear model. So import lasso. Lasso. Then next thing I need the metrics. So from scikit-learn import metrics. So let me import all of them. Then we'll load the data. So car underscore dataset is equal to pd dot read csv, and inside that I'm going to pass my data location. So now if I show you my card data, so guys, you can see this is the data. So here you have card name, years, okay, and here selling price is the label. Okay, so this one actually we have to predict what would be the selling price based on these are the features. Okay, you can see and again some categorical features are there, we also need to handle them. And if you want to see the shape, like how many records you have, so simply you can call this rep attribute. So 301 example and 9 column. Okay, now if you want to see whether it has missing value or not, just write record dataset dot is null. Okay, then dot sum. So there is no missing value. Okay, it's completely fine.
Now if you want to see the distribution of all the category, like fuel type, then seller type, okay, transmission, if you want to see them, you can see the value count. So let me show you. So this is the value count of like fuel type, like petrol you have 239 example, then diesel 60, and CNG only 2. Okay, then seller type you can see dealer and individual, transmission manual and automatic. So manual card is more, okay, in our data set. Now what we have to do, we have to convert all of the category to numerical representation. So for this we'll be using integer encoding. So here we have to create a dictionary. So let's say petrol I want to define with 0, diesel I want to define with 1, and CNG I need to define with 2. So this is the code. So if I execute, so this will change your field type. Then I will change for the seller type as well. So here dealer is equal to I'm making 0, and individual I'm making 1. Then for the transmission also, so manual I'm giving 0, automatic it's 1. Now again if I show you my card data.head, so you can see now everything has converted to the numerical data. Okay, now one thing guys, I don't need the card name. Okay, if you want you can also use the card name, but I don't want to take as of now, because if I show you the card name, if I want to show you the card name value count, so you can see that. So here you have okay, so it should be card name. See here you have lots of card. So guys, you can see here you have lots of card name, around 98 plus card name. Okay, that's why I'm not going to take all of the category. Okay, that's why as of now I'm not going to take the card name. Okay, so let's separate out my x and y data. So here is my x data. Instead of car and selling price, this is my x data, and selling price should be my y data. Now this is the data, and this is your level. Now we'll do the tentative split operation. So you can see guys, split size is 0.1, that means 10% data I'm giving for the testing, rest of the data I'm keeping for the training. Then we'll be training a linear regression model at the first. So let's define the linear regression and let's feed the data. Done. Now let's do the evaluation and see the accuracy. So first of all I will check on top of my training example, and I will check the r squared error, okay, root squared error. So you can see I'm using R2 score. Okay, so R2 score will give you the like accuracy you got here. See guys, 87% accuracy we got on the training example. Okay, now if you want to visualize the like the predicted distribution with the actual one, so here you can see I'm giving the actual one and predicted distribution. So you can see like all of the points are close. Okay, that means it is a linear kinds of things it is created, that means almost close. Okay, like some of the things it is missing, like this one, okay, like that, but the prediction is good. Now let's do the evaluation on the test data. So linear model dot predict on test data. So I'm going to keep yeah, let's calculate the R2 score now. See, on the testing data I'm also getting 83%, and if you want to see the distribution, so here is the distribution, and for this I'm using matplotlib. Okay, you can see. Now let's apply the lasso model. Okay, so lasso is having regularization parameters, so I think you know, if you have the underfit and overfit problem, you can use this model. So let's feed the data. Then I will show the accuracy R2 score on the training example. So this is the R2 score on the training example, 84, but in linear I was getting 87. That means linear is working better. Let's see on the test data as well, but before that let me show you the visualization. Okay, you can see this is the visualization, and now I'll do more on test data. Okay, so 87% I'm getting. Now if I show the distribution, so this is the distribution. Okay, now you can write the prediction code. Let's say if you want to do the single data prediction, you can also do it. So in my previous example I already showed you, okay, how to do it. So yes guys, that's how we can solve this problem statement. And again, if you want, you can also apply lots of feature engineering EDF part. So just go to the Kaggle notebook. So if you visit the Kaggle notebook, okay, so there are so many notebook. From there you can learn like various kinds of EDA and feature engineering tasks. But again, you can see this model is also giving you the good accuracy. Okay, you can also use as it is. So with that guys, thank you so much for watching this video, and I will see you next time. Hi guys. In this video, we'll be implementing another amazing project called gold price prediction using machine learning. So far we have implemented so many projects with different data sets. Even I also showed you how we can implement the entire end-to-end pipeline. So if you want, you can also convert this project as an end-to-end pipeline. Okay, the same template you can use. So first of all, let me show you the data, like where this data is present. After that, I will show you the workflow. Then we'll start the implementation of this project. Guys, this is the data. You can see this data is available over the Kaggle website. The dataset name is gold price data, and you can see this is the data looks like. So it has actually different features like SPX, then GLD, USO. Okay, based on that you have to predict the price of the gold. So here price in you can see this is the price. So the price you can see you have to predict in a euro or USD. Okay, you can see. So this data you have to download. So just click here, it will automatically download the data. So let me download the data. So here you can download as a zip file, and in the Colab notebook we'll perform the analysis part. So this is the workflow of the project. So first of all, we'll be getting the gold data. Then after that, we'll try to pre-process the data. Then we'll perform some basics data analysis part. Then we'll be doing the tender split operation. Then here we'll be training one model called random forest regression. Okay, so this model will try to train, and after that we'll try to do the evaluation. Okay, then you can do the single like data prediction. Okay, I think I already showed you how to perform it. So let's open up our Google Colab, and let's start implementing the entire project. So to open up the Google Colab, search colab.research.google.com and click here. Just take a new notebook. So I'm going to name it as gold price prediction. Now let's connect the notebook. So notebook is connected. So here, first of all, let's import all the necessary library I need. So I'm going to import NumPy as NP. Then I need pandas, SPD. Then I need matplotlib. So import matplotlib.pyplot as plt. Then I need cbond, so import cbond as sns. Then I need tenter split from sklearn, so from sklearn dot model selection, model underscore selection, import train test split. Then I need random forest classifier. It is available inside sklearn dot ensemble. Okay, I think you know that this random forest regression is the ensemble model. Okay, that's why it is available in the ensemble. And why regression I'm using? Because the problem statement, you can see it is a regression problem statement, because here you have to predict the price of the gold and it's a continuous data. Okay, that's why it's a regression problem statement. So import uh, random forest regressor. Then I also need the metrics. So from, okay, so I just need to write from sklearn input metrics. So now let's upload my data. So this is the data, let's upload it. Then I'm going to rename it, because sometimes whenever you will try to unzip, it will give you some issue. So that's why you have to rename it. Then you can unzip the data. So unzip, just give the data location. Unzip is done. Now here is the data, gold price CSV. Okay, Now let's try to load the data. So here I'll just write gold underscore data is equal to pd dot read csv is equal to, oh sorry, inside that you have to give the location of the data. So this is the location. Then after that, if I show you my gold data, data dot hit, this is the data, guys. Okay, so here you can see it has date, spx, gld, yeah, uso, slv. Okay, so these are some actually features of the gold, and based on that you have to predict the price of the gold. And here date is not required because uh, I mean that doesn't have any information. Okay, so that's why we'll try to remove the date. Now if you want to see like how many record you have in this data, so simply just write data.shape. So here you have 1290 example and 6 columns. Now if you want to see the information like how many integer variable, category variable you have, you can see that. So all the variables are you can say floating, and only this date, okay, it is the object type variable. So we'll try to remove this part. And if you want to see whether it is having missing value or not, simply just write gold data dot is null, okay, and dot sum. So you can see there is no missing value in the data. It's completely fine. Now if you want to see some statistical analysis, you can also see the describe of the data. So here you will be getting mean, standard deviation, minimum value 25 for 50 and 75, and max. Okay, these are the value. Now here like all the data you can see it is like a floating type data, and again it's a regression problem statement, so we have to also see the correlation, okay, correlation of the data. So whether any column is like highly correlated or not. So for this let's try to see the correlation. So correlation is equal to gold data dot core. Okay, so there is a method called core inside pandas. So if you execute, so this will give you the correlation value, but here it is telling could not convert to string to float, because what is happening here, you have one this one uh, categorical column. Okay, so that's why it's not working. So what I will do, first of all, we'll try to drop this particular data. So gold data dot drop, so column is equal to, I want to drop this date column. Okay, date column, and what I will do, I'll try to store inside uh, or let's do it in place is equal to 2, in place is equal to true. That means I want to do it permanently. Now let's see if I execute. Now if I show you my data, gold data dot hit, so now I think date column is not there. Okay, it's not there. Now I think this will work, so let's try. Yeah, so it is working now. It has all the correlation value. Okay, it has all the correlation value, but I want to plot it in a graph so that you can understand, okay, what is the correlation. Because by seeing this number actually I think there is a possibility you won't be able to understand. So let's plot a graph. So here we'll be using matplotlib to plot this particular graph. You can see this is the graph we are plotting. So if I show you, see, this is the correlation. So you can see this is the highly correlated number. That means if you get this blue mark, that means it's highly correlated, close to 1. And if you get this white mark, that means it's lowly correlated. You can see this euro usd, euro asd, this is highly correlated because these are like same column. That's why this color is high and the number is 1.0. Okay, then this euro usd and slv, okay, you can see this is also like little bit correlated, 0.3 around. So here you can consider. Then uso and usd, so this is having actually correlation and close to 1. Okay, so that's how I think you know that, guys, in statistics what is the correlation and how it helps us to perform the regression problem statement. So you have to understand. Okay, so with that you can understand whether your feature is has, so with that, guys, you can understand your feature is having relation with your target column or not. Okay, based on that you can
select the column. And if any of the columns is, let's say, highly correlated without your target, that time you can remove one of the column and you can keep only one column. I think you already learned in your statistics. Okay, I'm not going to explain. Now what we'll do, guys, we'll try to split the column between our x and y. That means here we'll try to separate out our x. So date I already removed, so I'm going to remove from here. So I'm only going to remove the GLD. That means this is my target. Okay, and inside x I don't want to keep the target, and inside y I want to keep the target. Okay, that means the price GLD. Now you can see this is the x and this is the y. Okay, so here one mistake I have done, guys. Instead of GLD it would be this one, nah? Because this is the price. Here I will try to mention it. Now it should work. Let's see. So now we can see it is fine. Now if I show you my y, so here is the price. Okay, now what we'll do, guys, we'll try to do the test split operation. So here I'm keeping 80% data for the training and 20 for the testing. Then we'll initialize our random forest regression, and n estimator is equal to, I'm taking 100. Again, it's a hyperparameter tuning. Okay, you can take any number. So I was trying with 100 and it was working fine. Okay, you can go to the documentation of random forest regressor, you will get it. Now let's fit the data. So I'm going to fit the data x train and y train. Now it's done. Now if I do the evaluation on the testing data, so let's see the prediction. So if you want to see the prediction on the test data, so this is the prediction, guys, I got. Okay, now what we'll do, we'll try to see the accuracy. So for this, let's calculate the R2 score. Okay, so I'm giving the original data and the predicted data, and here is the R2 score, guys. I'm getting 98%. Okay, that means this model is working better. And if you want to see the actual versus predicted result in a graph, let me show you. First of all, let me convert this thing in a list, then I'm going to plot with the help of matplotlib. So now if I show the graph, so guys, you can see this is the graph. Now you can see this is the actual value, this is the predicted value, and you can see both are close. Okay, that means it is working fine. So that's why I told you, guys, here now what you can do, you can convert this project in an end-to-end pipeline by referring my previous template, and you can actually complete the entire, let's say, implementation. So with that, guys, thank you so much for watching this video, and I will see you next time. Hi everyone, welcome to this project. So in this project we'll be implementing heart disease prediction system. So here we're going to train one classification model. So this model will able to predict whether a person is having heart disease or not based on some input features. So first of all, I will show you the data, how this data looks like, and I will also share the data and code with you so that you can also try with me. So guys, this is the data. Even this data is also available over the Kaggle website. If you search like heart disease data Kaggle, you will get this particular data. So I will share the data link, okay, in my Google Colab. So from there you can download. So you can see it is having different features like age, sex, okay, CP, then some parameter you can see. So these are the parameter actually related to the heart disease. So you can see some measurement number. Based on that, you have to predict whether this person is having heart disease or not. 1 means he is having heart disease, and 0 means, okay, this person doesn't have heart disease. Okay, so that's actually you have to make a classification model. And this is the project workflow, guys. First of all, we have to get the heart disease data. Then after that, we'll be performing some basic speed processing step. Then we'll be doing the test split operation. Then we'll be training one logistic regression model, and you know that it's a classification model. And after that, we'll be using the trained model, and user will give the new data, and it will predict whether this person is healthy or he is having the heart disease. Okay, so guys, let's open up our Google Colab and let's start the implementation. So to open up the Google Colab, just search for Google, colab.research.google.com, and here just take a new notebook. So first of all, let me add the data link here. Data link.
So here what I will do, I'll name the notebook heart disease prediction. Let's connect the notebook. So let's import all the necessary library. So numpy as np, then I need pandas, import pandas as pd, and I also need to download the data. So let me download. Now 10 test split I need. So from scikit-learn dot model selection, import train test split, then from scikit-learn dot linear model, import logistic regression, then from scikit-learn dot metrics, import accuracy. Okay, so let me import all of them. Then I'm going to upload the data here. So let's load the data. So heart underscore data is equal to pd dot read csv. Mm, So now it has uploaded. Now let's copy the path and here let's try to provide. So now if I show you my data.head, so this is the data, guys. So based on these features you have to predict the target. Okay, and if you want to see the shape, so this is the shape. Like you have 303 rows and 14 columns. Okay, now if you want to see the information about the data, so you can use the info function. So it will give you like the data data types, like you have integer data a lot, some of the data are floating, and yeah, so there is no categorical data. Okay, that means object type column. Now if you want to check the missing value, so just write is null dot sum. So there is no missing value in the data. Okay, now if you want to see the statistical uh, analysis number, you can use the describe function. So here you can see mean, standard deviation, mean, then maximum value. Okay, now I want to see like how many heart disease patient and how many healthy patients I have for this. Let's see the value counts. So heart data, so I think it's target. So I want to I will do value count evaluation. So value counts. Okay, so this will give you the distribution. So here 165 patient, let's say person is having heart disease, and 138 patient is having healthy. So that means it's a balanced data. Okay, now let's try to split our data into x and y. So x is equal to heart data dot drop. So here what I have to do, guys, I think you know that I'm going to drop the target only, because all the features are important, and axis is equal to 1, then y is equal to heart data target. So this is my x and y. So I can see this is the x and this is the y. Okay, now let's do the 10 test split operation. So here I'm going to keep 20% data for the training and 80% for the testing. And if you want to see the shape, so this is my original shape, this is the training, and this is the testing. You can see, so training data I got 242 and testing I got 61 only. Okay, now let's initialize our logistic regression model. So this is my logistic regression model. Then after that we'll try to fit the data. So you can see, guys, training is complete. Now what we'll do, guys, we'll try to do the evaluation. First of all, I will show the evaluation on the training data. So here I'm giving the training example. and this is the training accuracy. So training accuracy I got 85%. Okay, now let's see on the test data. So here is the testing accuracy, so 81, that means almost close. So again, this model is good. Now let's create a single predictor model. So what I will do, let's say I have one input data. So these are some, let's say, features, like you have seen different features you have. Okay, I collected. Now I want to see this patient is having heart disease or not. Okay, for this, first of all, I'll try to convert this data as a numpy array. Then I'm going to reshape it because it's a single data. Okay, then I'm going to pass in my model. Now if I show you, see it's 0, that means this person doesn't have heart disease. Now if you want to show it, you can use this condition: if predicted result is equal to 0, that means this person doesn't have heart disease, otherwise this person has the heart disease. Okay, now let me execute. Now see, this person doesn't have heart disease. Okay, now you can also change the number. Okay, and you can again execute, you will see that it will give you the prediction. Okay, so guys, that's how we can implement this particular project, and if you want, you can also convert this project as an end-to-end pipeline, okay, by using my same template. So yes guys, I hope you liked it. So thank you so much for watching this video, and I will see you next time.